Logistic regression in STATA. How to conduct binary logistic regression analysis in STATA. Let's suppose we would like to predict who's likely to be born low birth weight based on maternal smoking during pregnancy and maternal age. So let's take a look at the measures. Our outcome variable is birth weight, which is a binary variable where 0 stands for normal birth weight and 1 is low birth weight. We also have two independent variables, and both are categorical, namely smoking during pregnancy, where 0 is no and 1 is yes, and maternal age, which consists of three groups. 1 stands for women whose age is between 20 and 34 years old. Then 2 stands for or includes those who are less than 20 years old. And 3 includes women older than 34 years old. Now, the outcome variable, when is binary, we usually use 0 to denote the group that is likely to be healthy, or the group that is likely to have the larger number of cases, while 1 is used to denote the group that we're trying to predict. And usually that group is the one that is likely to experience adverse outcomes. So in this case, we want to predict who's likely to be born low birth weight. Therefore, 1 is assigned to that group. So how do you choose the reference group in a categorical variable? A reference or comparison group in a categorical variable is often chosen based on whether a group comprises a normative state. Normal birth weight, having health insurance, no smoking, all of them constitute examples that are normative for a large segment of a population. Therefore, as we explained earlier, in the birth weight example, we choose to predict low birth weight for the outcome variable, and for the independent variables, the reference groups will be no for smoking during pregnancy and 20 to 34 years of age for maternal age, as most women who have babies are between 20 to 34 years old. Remember that choosing reference groups for the independent variables is an important step when the regression coefficients are expressed as odds ratios. So let's go back to the example. So when we start the analysis, we want to compute some basic descriptive statistics. And since these are categorical variables, we want to conduct some tabulations which are appropriate since both here the dependent and independent variables are categorical, and use the chi-square test to test for any potential significant associations between these two variables. So we can use the command tabulate, then the variable tobacco, which in this case stands for smoking, and it's the variable that goes into the rows. Birth weight is the dependent variable, and we place that second so that it goes into the columns. Comma, we would like to compute column percents and compute the chi-square test. So if we look at the line below, we see the value of the chi-square test, which is small, and therefore it yields a larger p-value. So what we observe in this example is that there is not a significant association between birth weight and smoking, because the p-value of 0.170 is larger than the level of significance of 0.05. But overall, if we look at the distribution of the percents in the classification table, we observed that a higher percent, 20.2% of infants was born low birth weight to mothers who smoked during pregnancy. However, this association was not statistically significant. Now, let's take a look at the association between birth weight and age. So we run the same command as before, tabulate, but this time, instead of smoking, we have age in the command line. And here we notice something similar as previously, where the association is not statistically significant because the p-value of 0.587 is larger than alpha. Although a low birth weight infant was more likely to be born to younger mothers, as you can see here from the percent distribution in the table, the finding was not statistically significant. Although we did not find any significant association between smoking and birth weight, and age and birth weight, we will run a logistic regression model for demonstration purposes. The command for logistic regression in STATA can be as follows. You start with the command that indicates logistic regression, and that is logistic. Then you place the variable birth weight, which is our outcome variable. The outcome variable or the dependent variable has to go after the command logistic. And then we place the independent variables. So we start with tobacco, and as you can see, just before tobacco, you notice the letter I. I indicates that the variable is categorical. If you have a continuous independent variable, then you omit I. Now, you also notice that there is a B next to I. The B indicates that we are asking STATA to compute odds ratios. So it will display odds ratios on the output as opposed to just the regression coefficients. Next to the B, you notice a 0. The 0 in the parentheses shows that your reference group or comparison group for this variable is the group that is assigned the value 0. In our case, it corresponds to the group that did not smoke during pregnancy, and therefore that's the reference group. Now for age, the reference group is the group that is assigned the value of 1, and that is the group of women between the ages of 20 and 34. So once we have the command line ready to go, we run the analysis. And below you see the output associated with these variables in the model. So let's take a look at the first tab line, which indicates the number of observations, and the sample size basically here is 1040 observations. Then below we have two lines highlighted in green. The second line, highlighted in green shows the chi-square test, which is 2.66. This is the likelihood ratio chi-square test, which tells us that its value of 2.66 with a p-value of 0.4472 means that the model produced below as a whole does not fit significantly better than an empty model, meaning a model with no predictors. Basically, this is not a good model. Perhaps we expected this to a certain degree because the associations between each independent variable with the dependent variable were not statistically significant. So in this case, the model is not a good model overall. Now, below the highlighted green lines, you'll see a highlighted line, a line highlighted in blue, and that shows the pseudo R squared, which is 0.0046. This is similar to an R squared of multiple linear regression. Usually, we do not interpret this measure because it's not a reliable one. But either way, it is a very small value. Typically, we do not interpret findings that are not statistically significant. However, in this example, we will go ahead and interpret the findings just to demonstrate how you interpret findings related to logistic regression. Now, recall that we asked STATA not to show the regular regression coefficients, but instead we asked for odds ratio. And the reason we did that is because the regression coefficients in logistic regression are log odds, and those are hard to interpret. Therefore, when we convert those to odds ratios, just like we covered in the previous set of slides, makes it easier for us to interpret the findings. So let's interpret the first odds ratio in this output of 1.46. What does this really mean? Now, recall that the reference group for this variable, smoking during pregnancy, is not smoking. Therefore, in this case, we're comparing the odds of having a low birth weight among those who smoked during pregnancy versus those who did not smoke during pregnancy. So we would then interpret this odds ratio as follows. Mothers who smoked during pregnancy are 1.46 times more likely to have a low birth weight infant compared to those who did not smoke. Now again, this is not as significant since the p-value based on the z statistic the STATA is using is 0.184, which is larger than our level of significance at 0.05. Also, you may notice that the confidence interval associated with the specific odds ratio ranges from 0.83 to 2.57. So this confidence interval contains the value 1. When the value of 1 is in the confidence interval, the odds ratio associated with a specific variable is not statistically significant. And of course, this is in agreement with the conclusion from the p-value. Now let's try to interpret the odds ratio related to the variable age. The variable age has three groups. The group of women between the ages 20 and 34 was selected from the beginning to serve as the reference group. Therefore, we're comparing the odds of having a low birth weight in women less than 20 years old, and that is expressed by the value 2 that you see in the table, to 20 to 34 years old, and then we're comparing the odds of having a low birth weight in women older than 34 years old, and that is indicated by the value 3 that you see in the table under age, to 20 to 34 years old. So given this now, we can interpret the first odds ratio associated with the group of women between the ages of the group of women less than 20 years old. So one may say that younger women are 1.27 times more likely to have a low birth weight infant compared to women between the ages of 20 and 34 years old. This finding, however, is not significant since the p-value of 0.437 is larger than 0.05. The same can be concluded by just looking at the 95% confidence interval for this odds ratio, which goes from 0.69 to 2.35. And this confidence interval, as we can see, contains the value of 1. Now, on the other hand, we notice that older women are 0.84 times less likely. And we say less likely because this value of odds ratio is less than 1. So they're 0.84 times less likely to have a low birth weight infant compared to women between the ages of 20 and 34 years old. Again, this is not a statistically significant finding because the p-value is 0.652. The same can be concluded by simply observing the 95% confidence interval that ranges from 0.39 to 1.8. Now remember, when you write the findings from a logistic regression output, you want to make sure not only you show the value of the odds ratio, but also you display the 95% confidence interval next to the odds ratio. This is important because for many reasons, but one of the reasons is that confidence interval can tell us how stable or unstable, how accurate or not so accurate the odds ratio may be. So if you obtain a confidence interval that is very wide, for instance, a very wide confidence interval for 1.27 might be going from 0.69 to, let's say, 30.5. That is a very wide confidence interval, and it might indicate issues with the cell size for this particular independent variable relative to the dependent. In other words, there may be too few cases for this particular group that is causing then the confidence interval to be too wide. So in other words, we want to show the confidence interval associated with the odds ratio in that same sentence when we do the interpretations. Overall, you do not need to interpret non-significant findings. Instead, you should dedicate one sentence to non-significant findings by saying that maternal age and smoking during pregnancy do not have any significant effects on low birth weight. However, in this example, I provided interpretations of the non-significant findings just for demonstration purposes. Now, these results may seem a bit unusual given that smoking during pregnancy is usually associated with low birth weight, but the findings of this study could be due to this unique sample that may not be representative of the population.